a question. Would you like to see the amount of snow that I have right now? Because I have probably the most interesting amount of snow. So I'm going to take you guys on a little tour. I want you guys to see an interesting place. I'm staying with a friend right now, my best friend, Craig. And Craig has an apartment on the 31st floor overlooking a place called Port Everglades. Now, if you can see, we are now facing southeast out of the Atlantic Ocean. If we kept going in that direction, we would hit the Bahamas, okay? And if we kept going there, we would hit probably Africa. Now, I'm gonna now turn to this direction, and this is called Port Everglades. You see that big coming in? This is where all the container ships come in with all of the products that we buy. So anytime you guys order from Amazon, the reason why you're able to get products is because these ships come from places like China and all over the world where they manufacture, and then they bring on these huge container ships. You can also see the airport. I don't know if you see an airplane just took off from the airport. And then this is Miami all the way down south. And this is kind of a neat place. So I took you out here for a reason. Number one, this is Florida. There's no snow. We're not getting snow. I will tell you though, that my first year in Florida in 1976, Mr. Kramer, there's a snowstorm in Florida, okay? There was a snowstorm in Florida, and it wasn't a real storm. I mean, it was just, a little bit of snow, but that was a really interesting thing for me because I left New York thinking there's no snow in Florida, and sure enough, there was snow in Florida. So I hope you guys have a good one. Now, I want to show you what is unusual about the balcony that I'm showing you right now. John?
It's a lot longer than a normal one.
Guys, this is one of the longest balconies I've ever seen. Now, I'm going to take a walk right now, and I'm going to step off. Let me see how big my steps can be here. I'm going to step off by 6. Are you ready? So I'm going to go 6, and now go.
18, 21, 36,
12.
42.
Say 12. You don't want to count. No, you don't want to count without my steps because it'll have no application. You have to wait till I say go. So I've only taken 2 steps. I'm going to do it again. I'm going to take the first
18.
step. You tell me the number. Go.
24.
That's it. I'm only at 6. I've only taken 1 step. Let's try it again. I'm going to start again, and the first one is going to be 6.
6.
Go.
12,
Go.
18,
Go.
24,
Go.
30,
Go.
36,
Go.
42,
Go.
48.
Okay, everybody stop. I only hear 1 student. I only hear 1 student at 48. I want to hear everybody. On 3, 1, 2, 3. After 48, go.
54,
54.
Go.
60,
60.
Go.
66,
Go.
72,
Go.
78.
Now, I want to tell you that our estimate did very well. It's not perfect. When you step something off, there's always a little inaccuracy. So I actually only have here exactly 75 tiles. So there are 75 tiles from end to end. Now, who can tell me what is the, if each tile is 8 inches, if each tile is 8 inches, how many inches long is this balcony? Do not call it out loud. And I want you to pick up your pencils. 75 tiles, they're each 8 inches. Yeah, so it's important, yeah, let's see. So how many inches is this going to be? Okay, Luke, what do you get?
I have 600.
And Claire, what do you have?
600.
Great. Let's see. What about John? How did you come up with yours?
I just did standard algorithm, 75 times 8.
Okay, that's cool. What about Adalia? How did you do yours?
Also standard algorithm.
Great. Anybody else do a different method than standard algorithm?
I don't understand.
I'm not going to tell you that another
Yes, I need
method is
more of that.
better, but I actually do have one that's better. Okay, guys, you ready for this? Who can tell me what is the number 8? What is the number 8? And Michelle Hipwood, sorry, Cameron, could you change your name? And
Yeah.
Cameron, could you explain what the number 8 is?
Actually, never mind. Actually,
Oh, no, just tell me. What do you think the number 8 is? Who knows what the number 8 is? It's a very special number. There's about 3 or 4 ways to describe it. Isabella?
Is it the width?
Ooh, it actually, since the tiles are all square, the length and the width are actually the same. Luca, what about you? You'll have to unmute yourself.
Is it like 2 to the third power?
You'll have to speak a little bit more clearly.
Is it 2 to the third power?
Ah, so guys, 8 is 2 to the 3rd power. It's a cubic number. If it's a cubic number, 2 times 2 times 2, can you guys speak Turkey? Are you ready? Double, double, double. Good. Double, double, double. Come on. Double 75 once. Go.
150.
Double 75, double 150,
300.
300.
and double 300.
600.
That's my method.
1,200.
How many of you did? Now, I had a student in the last class do a really cool algorithm. He did distributive property, but listen to this. Instead of splitting up 75 to 70 plus 5, which is what I would have done, and then I would have done 8 times 70, 560, plus 8 times 5, which is 40, that's 600. He was even more brilliant. I loved it. He split up 75 to 25, 25, and 25. And he said, Mr. Kramer, 8 times 25 is 200. And 3 of those is 600. So there are many really cool ways to get there. Now, if I have 600 inches on this balcony, who can give me the equation, not the answer, the equation for how many feet is this balcony? Who can do that? I've got hands up. I want new hands up. Alexander, how do we do that? I have 600 inches. I need the number of feet. What do I do, David?
I would do, there are 12 inches in a foot, but we don't have 1200 inches. So we have to separate 600 into 1200 equal categories. So I say 30 feet because you would take one of the zeros off and then cut the 60 in half and then get 30.
Yeah, David, I like your thinking. I think that maybe there's a little tweak there. Claire, can you help me with that one, please?
60 divided by 12.
Ooh. Do you guys know what 60 divided by 12 is?
5.
Guess what,
50.
guys? That's
50.
5. But it's not 60, it's 600. So instead of
This is
5,
50.
it's 50.
50.
So
And the
David,
zero.
your explanation was correct, but you were off in the number. So if you think of 1200, David, 1200 would be 100 feet,
Yeah.
right? And then half of 100 feet is 50 feet. Now, everybody, how many times do you think I could walk halfway to the other wall? How many times do you think I could do that until my face
Try
is
to find like a
right up
backwards
against the wall?
format.
I'm gonna start cooking.
So can everybody send me a chat, please, with the number? What do they think? How many times do they think I could walk halfway to the wall? And I mean, when will my face be right in front of the wall? So I should see a chat from everybody. Yes, and Isabella, I know you heard the explanation. I want to make sure that you don't do that next time. Try to, let him be in a separate room, because we're doing different math, that his group and my group, but still you want to be able to discover these things. Oh, I got some great answers. I got some
Should I not
amazing
put in
answers.
an answer then?
And the person answer that I like the best so far, well, I can't really decide who I like better. Right now, my favorite answer is Luca and Adalia said, well, Adalia said never, and Luca said 150,000. And I know what you mean. Adalia, you meant infinity, right? Right? Infinity times?
Yeah.
And Jesse's is also awesome. Jesse said 9 times. Now, how is it possible that I could like Luca and Adalia's answer and also like Jesse's answer? So guess what, guys? Let's take a ride. Are you ready for this ride? Think of Disney World, but 31 flights up. Here we go. You ready? I am going to get started. Can you guys see where the halfway mark is right now? You like visualize in your head? All right, here we go. I now have to walk 25 feet. 1, 2, 3, 4, 5, 6, 7, 8. Are you ready? That was 1 half. So everybody hold up 1 finger because that was 1 half. Now I'm going to do the second one. That's 2 halves. Let's do the third one. 3 halves. By the way, what's the fraction that I have left to travel? Who can tell me? Say it out loud.
1/8.
Yep, exactly 1/8. After my first half, I had 1 half left. After my second half, I had 1/4. After the third one, I have an 1/8. Now the fourth one, and I have a
16.
16th. Say it out loud. Now I did the fifth, and I have what?
30.
That I have 1/32nd, or as my first grader said, 1/32th. Are you ready? Now I'm going to do my 6th. and I want you to see where I am. I am not up against the wall yet,
So
but watch what happens on my 7th. Is my face almost at the wall? Guess what,
Yeah.
guys?
Almost.
It, I can't do it.
Not at the wall.
But watch this, guys. Look at my feet now. Do you guys see how close my feet are to the wall?
Yeah.
Now, using Adalia's method, I'm going to go halfway, and then halfway, and then halfway. Guys, can I ever hit the wall?
No.
You can never hit the wall. Now, obviously, we are not going to go to the atomic level. What would we need if we went to the atomic level using atoms? How would we even see them? Does anybody know?
I guess the microscope.
Oh, Jesse said microscope. Hannah, what do you think?
I was going to say the same thing.
Yeah, but guys, it's a special microscope. It's not the kind of microscope you've seen in science. It is called a micron. A micron microscope can see at the atomic level. If you ever have an opportunity to look under a micron microscope, you can see to the atomic level. I'm not even sure that that's what it's called, but I know that they have these amazing microscopes where you can see tiny, tiny. Now, everybody take their computer with them if they don't have a desktop, stand up and go to your longest hallway. So just like Mr. Kramer is at his longest hallway, try to take your computer with you.
Can we turn our cameras off while we're moving?
No, no, no. Don't turn your cameras off. Okay, now, as you can see, my back is to the wall. In fact, put your head right on the wall. Okay, now, I want you guys to visualize, and Isabella, I assume that you're at a desktop so you can't pick it up, right? Okay, so Isabella, what I'm gonna ask you to do is get up and go to the end of your room by that, it looks like a TV or a picture of your family on a boat. Okay, so go there and then you're gonna walk halfway. Alexander, you should do the same thing. Get up.
I have a desktop.
That doesn't matter. I want you to get up in your room and I want you to go to the longest distance in your room because it really doesn't matter. Now, is everybody ready? Everybody now visualize the halfway point and take their first. Go. Now, I'm not interested in you taking baby steps. I'm interested in how many steps it takes you to have your face right up against the wall. Okay, go. That's 2 for me. 3, 4, 5, 6, and now here I am, and I'm gonna do the 7th. And my face is right up against the wall. You could make an argument that I could go 8, maybe 9, like Jesse said. How many did you guys go? Just
I wasn't
fair.
counting.
How many did you do?
7.
Cameron, how many did you do?
I wasn't counting. Can you do it again?
Okay, David,
6.
how about you, John?
What?
How many?
Sorry. Like I did 8.
8. How about you, Luca?
I think I did about 10, but I wasn't counting.
All right. What about you, Hannah?
I think I did about like 7 or 8. but I wasn't
And what
counting.
about you, Alexander?
I did 13.
Okay. And how about you, Claire?
I did 7.
7. And Luke?
Oh, this is like is this halfway? Or
Well,
So,
I can't really tell because I'm not at your house, but you
well,
have
I
to
mean,
halfway to the wall opposite you.
yeah. Okay, yeah. I'm around like 7 to 8.
7 to 8. How about you, Isabella?
That's what I meant. Yeah.
Yeah, and Adalia?
14-ish.
Whoa. Now, but Adalia, when you hit the 7, wasn't your face right at the wall?
Sort of.
Yeah, so 7 is really the number, guys, where your face is right at the wall. Luca?
Can I go downstairs and try again to go like my longest hallway that's smaller than your
Absolutely.
hallway?
Absolutely. Guys, I want you out of your seats, man. This is my favorite lesson. And guess what? These lessons are going to get more like this because the next time we meet, I'm going to be on our new boat, and you guys are going to see some really cool stuff that I'm going to teach you. John?
Is it the same for every single hallway? Because there's always like the halfway for each.
Yeah, guys, I wonder if we can even take a picture of the United States and think of doing this from California to Boston. Would you guys like to try?
Here.
You guys want to try doing this from California to Boston?
My computer froze for a little bit, so can I keep my camera off to see if that helps?
Of course. And by the way, the reason why Adalia's computer froze is because it's freezing up in Boston, right?
Yeah.
I'm on the other side of you.
Right now it's 36, so not quite freezing where I am,
Oh,
but
quite
close to it.
Well, I am back inside. I
Yeah.
much prefer to be
Yeah.
outside, but I'm back inside. And I want to do an exploration with you now to really expand these ideas. So everybody, let's do something really simple. Let us take a piece of, do you know what this paper is called?
Cardstock?
It's called 8.5 by 11 paper. This is normal paper that you would put in a printer in the United States.
I need a piece of paper up.
Yes, in Europe, by the way, in Europe, this paper would be called A1. It's a little bit different. A1 paper, I think, is maybe it's 9 by 12, but I know that this paper is 8.5 by 11. All right. Now, what I want you guys to do is this. I want you guys to fold the paper in half, and I want you to write a fraction. By the way, do you see how I'm folding with my nails? I'm folding with my nails, and I write the fraction right on the page.
Wait, any fraction?
No, the fraction that this is. So this is 1/2 because when you open it, you have 2 equal pieces. So you write 1/2. Then fold it again and write that fraction. And then that's my second fold. By the way, count your folds as you fold.
This be a fourth, like your second one?
My second one is a 4th. And guys, don't take my word for it. After you do your third fold and you see 1/8, please open up your paper. And if you open it up and you have 8 equal pieces, you know that you were right, that you had 1/8. Okay? So that was 3 folds for me. Now I'm about to do the 4th fold, which gives me 16 equal parts, or 1/16 as a fraction. And then I'm going to try for a 5th fold. And I'm going to write this fraction. I told you what my student said. She called this 1/32. 1/32. Okay. There we go. Good. We're doing well. And then I'm
I
going to
just
try.
went to 8. That looks really cool. So it kind of not really spirals in. I don't know if I did that right.
So how many folds were you able to do, David?
I did 4 before this paper just kind of went, yeah.
Okay, well, I have to tell you, I am done at 6 folds. So
Same.
I cannot fold any more than 1/64. Was anybody able to get 1/128th?
I'm trying to. I haven't gotten far enough to
I'm
load it.
trying to too.
John, how many did you get?
30,
164.
32nd.
I got 164.
You got 1/64? Now,
I can't fold that.
I do have to tell you, there is a method of cheating, but I like cheating sometimes when it's creative. I put this underneath the leg of my chair. I'm going to show you right now. I don't know if you'll be able to see it, but I'm going to
Oh,
put it under the leg of my chair. And what it's going to do, yep, I think you can see it, is it's going to help press it. And I'm even going to sit on the chair, bounce around a little bit, give it a little, a little weight. You know what, guys? I still cannot fold it any more than 6 times.
I got it to 1/64th, and I think how it's kind of cool how if you follow the measurements, it kind of has a weird spiral to it.
Yeah, that's right. Yes, John.
can I unfold it now?
Oh, by the way, before you unfold it, Claire, I'm interested in yours because yours had a different shape to it. Can you tell me how many folds you did?
I could only do 5.
But Claire, don't you now have, well, you know what, Claire, I'm not going to give it away. I'm not going to give it away. Everybody open it up.
I'm trying to fold it.
Can I
And
use
make
it?
a rectangle with your pen or paper that is, for instance, my rectangle is a 1/64. So I know that there are exactly 64 pieces of that size that make up my whole. Now, what if I told you that human beings, and we are human beings, can actually do 7 folds?
I'm not too sure, but probably yes.
With a different piece of paper?
No,
I might
no,
know
no, we're talking with regular 8.5 by 11. And what I'm going to do right now is I'm going to take this guy and I'm going to throw him aside. And I'm going to ask Claire to actually lead us in this next exploration. Everybody pick up a new piece of paper, please. And Claire, do not fold it. Do not fold it. Claire, tell us how, in fact, Claire, pick up a separate piece of paper. Show us how you
I need to get one.
Okay, go get one.
Yes, and
I'll be right back.
Okay, everybody go get their paper.
You make a string and then you fold it
I
together.
don't think I know how.
Now, since Claire doesn't have her paper yet, we have to get going, guys. Watch this. I want you to take your paper. Now, John, talk to us. John, open that up, please, and tell us what you did differently.
Instead of doing like hot dog fold, a hamburger.
By the way, other people are speaking right now. And John, I want to hear you, buddy. So go for it.
You fold it in the other direction so it's like thinner.
Okay, everybody, this direction is called hot dog.
Yeah.
Yeah. This direction is called hamburger. This direction is called hot dog. And it literally, resembles a hot dog and a hamburger. But do not put mustard on it or relish. It will not taste good. Trust me, I've tried. This is one fold, right 1/2. Now, your second fold, hot dog. Now, guys, somebody's making very loud noises with their paper. Try to be a little bit more mindful of the noise that you make because everybody hears that. So now I have done a quarter because I've done 2 folds. Now I'm going to fold hot dog again using my nails. And now I have 1/8. So Claire, you have inspired me because I have a feeling we might be able to get 7 folds.
It's really
Fold-
easy right now.
Guys, can you fold hot dog one more time, please?
I tried it and you can.
How many people got 1/16 hot dog?
I did.
I did.
It's super thin.
Everybody, yes, Adalia?
Never mind. I
Okay,
was just saying that I got.
Hamburger. We
awesome.
call it hamburger
Now,
now.
everybody go hamburger on me, all right? I want everybody to now
This is a thin hamburger.
fold it. And Claire, that's why I thought, Claire, that you should have kept going because this is the 5th fold. And guys, I know that I'm gonna be able to do more. So I have 1/32,
You can't write it.
1/32 right
I
here.
can't write on it.
And everybody now, let's go to the 6th fold, which is 1/64. And some people actually, what they do is they put this inside a door jamb and they close the door like to make it thinner and thinner and thinner.
You can do it.
Guess what, guys? This is 1/64. You think we could do one more hamburger?
Yeah.
I did it.
Let's do it.
I just did 128th.
Oh man, that's cool.
It is like physically possible to go further. Like the paper has room to go, but I don't think I'm strong enough to bend it.
Well, I know that I am not. And guys, if any of you got 1/128th, that is the most that any human being could fold a regular piece of paper in half.
It just like doesn't move if I try. It just comes apart.
Now, what would you say if? Oh yes, Isabella.
Pretty sure I went the wrong way of folding it. I think I did it.
So how many folds did you get, honey? Did you record your fractions?
Huh?
Did you record your fractions as you went?
Yeah, and then I lost them while I was folding them. So.
Oh, now guys, I want
I
you
got
to
one for me.
do what John just did. Open them up and then make a
I'm trying.
rectangle that should be 1/128th.
Okay.
And I really love this, guys.
Hard to open. It's
Ah,
all like sticking
I'm
together.
actually struggling.
oh
Never
my
thought
God.
I'd say that, but I'm struggling.
Guess what, guys?
It goes down and then you have to flip it to the back.
Oh my god.
So guys, look at my 1/128th. That's my
Wait,
one.
that's how big yours are?
Yep.
Mine's up in the corner.
Now, guys, let's check our math. How many units do you have across? Ready? 1, 2, 3, 4, 5, 6, 7, 8. I have 16 going one way.
Oh, no, I have 16.
Which across?
I have 16.
I have 16 units going across, and I have 8 units going down. And if you multiply 16 times 8, oh, by the way, isn't 8 double, double, double?
Mm-hmm.
So go ahead, guys. 16 doubled 3 times. Go. 30.
32, and then 32, 64,
128.
And that's the proof. That's the proof. Now, would you like to see me do 8 folds? That's nice, David. I like that. Would you guys like to see me do 8 folds?
Can you?
Nope.
Maybe even 9. Now, does that make me superhuman, or am I going to do something a little different?
Are you going to use like a big
A little
piece of
bit
paper?
different.
Now, wait a minute. Before I show you, David said something that you guys need to hear. Go ahead.
You're going to use a bigger piece of paper because you can fold it more times because you have more area to fold.
Now, oh, wow. Cameron, hold that up for everybody to see. Look at Cameron. Cameron actually made all 128 boxes. Wow. Cameron, that's so cool. Now, guys, I introduce you to my favorite paper. It is unused. I want to emphasize unused toilet paper. Now, if your parents allow you to do this, you can literally set this out on your entire hallway. Now, Luca, I happen to know your place, and I know that you have some very long hallways.
Yeah.
So I would suggest that everybody right now go over to Luca's house. No, I'm kidding. Go into your house. No, don't do it right now. But when you're done with this class, if you could lay the toilet paper out all the way along. Now, it is not easy to fold in half. I just cut off part of it, and I'm going to fold this in half right now. And guys, this is 1/2. Now I'm going to do one more half fold. So that's 2 folds. Now I'm going to do one more. By the way, that's 1/8.
Sometimes she likes eating.
Do you think
What? That's
now
huge.
I'm going to do a hot dog, and that's 1/16. Hot dog, 1/32.
32.
And I'm going to do one more hot dog.
64.
Now I have 1/64. Now watch this. This is actually 1/64. And so as I go to hamburger, 1/128th.
Oh wait, we can't do this. Fly, can we?
1/256.
And guys, that's already 8 folds. Are you ready for 9th?
Can you do it again?
And that's it. 1/512.
512.
Now I'm gonna write
It's
this.
just amazing how much toilet paper can fit into one little small space.
1/500.
Yeah.
Guys, look at this.
Did you want to fold it? That would be
1/512.
interesting.
Now, guys, I want to explore an experiment with you. I just thought of this. I've done this lesson for many, many years because I love the power of 2. But I just thought of something. What if we put this in water?
Yep, much easier to
Guys, I am going to take my orange juice glass and I'm going to take some water.
Doesn't toilet paper become wet when you put it in water?
Oh, it's going to be wet, but I'm wondering will it allow me to fold it again, John? Now, I'm gonna, I can't really, if I drop it, I might not be able to get it out. Uh-oh, I dropped it. Uh-oh,
Get it?
I think I got it. Whoa, I lost it. All right, here we are.
Oh no.
I'm making a big mess. Now, I think that this is it. This is my 1/5/12. And what I'm doing now is I'm wringing out the water. Oh my God, I'm getting water on my computer. That's not good. Okay, you know, I would do anything for you guys, but I don't want to destroy my computer just yet.
Come have some dinner with me.
Okay, you guys ready? Do you think I could do it again?
Yeah.
Yeah. Really
Now,
do it.
even though you know that I cheated when I did this with water,
1,024.
guys, if I open this up, which I won't be able to do now that it's wet, it would be 1,024 individual pieces that make this up. Now, one of the amazing things, now, by the way, you know, guys, that I did not use a full roll of toilet paper. So
No, but you can make like over 100,000, I bet, with like a full toilet
guess
paper.
what, guys? I'm gonna challenge you to do more than 9 or 10. I don't think you can do it.
Just a minute. Can we
Using the whole.
Now,
oh yeah, I can pay for one roll.
wait, say again, Luca.
I can probably like buy it for my pay.
Now watch this, guys.
I'm gonna take it together.
Now, what I'm gonna do right now is I am gonna go to the document and I want you guys to see something else. I did some pictorials here for you where I showed you what it actually looks like to go halfway, halfway, halfway. And it kind of is fun to think about. And then I thought to myself, what if we went 1/3 of the way to the end? And again, 1/3 to the end, and 1/3 to the end, and 1/3 to the end. Don't I get to the end faster?
Yeah.
No.
There's no end.
Oh, guys, I'm only able to do 1, 2, 3, 4, maybe 5. If I do 1/4, guys, 1/4, 1/16, 1/64, I'm already at the end. So I'm only going to be able to get maybe 4 times. Now, David, I think, said something interesting. Maybe it was John. Talked about kind of a spiral. So what I did was on page 10 of your packet, or page 9, sorry, I created an 80 by 80 array. And I colored in every fraction and did it in a spiral.
It's
Now-
the Fibonacci sequence.
Yeah, oh, now that's an interesting comment. Let's see if it is Fibonacci. Are you ready? Let's see if I can do this.
Yeah, that's how that it works.
Yeah, you know what? I don't like my curves. I'm going to do it again. Let's try again. If I go, the problem is every other one is a square and every other one is a 2 by 1 rectangle. So
Yeah.
it does make a spiral. So whoever said that, it really does make a beautiful spiral. And then, of course, it gets lost at the atomic level. But
It's kind of like a squarely spiral.
now, guys, do you see what happens if I go in and I what is it called? I magnify I can still go and still go and still go. Now, I don't know if I can magnify this anymore. No, I can't. That's too bad. All right. So now I want to show you something a little bit different.
You can.
The next thing I want to show you is what this looks like on a graph. So this graph right here has an equation that is y equals 50 times 1/2 to the x power. And what that means, guys, is check this out. Isn't this point right here where I started 0 halves at 50 feet? Do you remember that on my balcony?
Yep.
And then I went 1/2 at 25 feet. Help me with the next one, please.
2.5.
12.5.
12.5.
What about the next one?
6.25.
1,
And the next one?
4,
Oh,
3,
12.5.
Yep. 0.125 or 1/8. That's 3 1/8. What's the next one?
5,
5 and 10.
Well, it would be a 1.5. Come on.
500.
2 and 5. And guys, as you can see, it's getting smaller and smaller and smaller. Oh, and look what happens at the seventh. I'm almost at the
Wow.
Now, what would happen guys, if I did thirds? So halves, 7 halves bring me almost to the wall. 5 thirds bring me all the way to the wall. 4 fourths bring me. Would you guys like to see these curves up close?
yes.
I'm going to show you right now. So guys, this is the 1/3. Now, let's do this together. We know that the first one is 50 feet. What would 1 be? What is 1/3 of 50? Come on, what is 1/3 of 50? 3 goes into 5 once. Remainder of 2. 3 goes into 20.
6, remainder of 2.
So that's 16 2/3. Oops. 16 2/3. Now, look at the next one, guys. What is 1/3 of 16 2/3? So 1/3 of 16.6 repeating. Come on, help me out. 3 goes into 16. How many times?
5.
Come on, guys. 5. Alexander, I don't see your eyes. I want to see your eyes.
1.
Remainder 1. Point. Yep, that's it, guys. So it's 2, 5.5 repeating. And let's do it again. Let's do 1/3 of 5.5 repeating. Come on.
Oh wow. 5. Wait, no. 1.
1.
Remainder of 2.
So 3 goes into 25. 8 time remainder 1. And so this one, guys, is 3. And then that would be 1.83 repeating. And guys, look what happens now. I am getting so close to the wall. So these functions are called exponential functions. This one's even cooler because it goes to 1/4. So it goes from 0.50 to 1 what? Who can say that? Raise your hand. Luke, are you working on this? Pick up your pencil, guys. Hannah?
12.1, 12.5.
Wow. Wow. Nice work. Now, who can do 2? Who can do 2? It would be 1/4 of 12.5. And if you want to, just write out 12.5, divide it by 4. Luca,
3.25.
very close, very close. It's 3.125. So very, very close. 3.125. And guess what? On the next one, we're almost at the wall. Who can do the next one? Let's write it out. 3.125 divided by 4. And I'm not going to say a word. I want you guys to work it. Everybody should be with their pencils. So on 3, guys, what'd you get? 1, 2, 3? Anyone?
0.7825.
Very close. It's 0.78125. Notice that 4 goes into 32 8 times. 4 goes into 5 once. With the remainder of 1, 4 goes into 10 twice with the remainder of 2, and 4 goes into 25 times. And so, guys, you can see that having, thirding, quartering really, really makes it fun. Now, everybody go to page 6. Everybody go to page 6 in their document. And I want you to try to create that spiral that Mr. Kramer created by first doing half, and then half, and half.
It's on page 5 for me.
Oh, I'm sorry, guys. It is page 5. My bad.
Oh, it's on page 6.
It is page 5, I think.
Well, on page 5, mine says how many times can you half this square before the regions get too small? Is that it?
That is exactly it.
All right.
And after you do each one of them, write the fraction you created. Adalia. Adalia, you raised your hand?
I did.
Yes.
It was left over.
Oh, that's okay. Now notice, guys, that I had to zoom in. It's easier for me to write small like this. Wow. 4,096. 8,892.
Wow.
1,384.
Getting too small for my pencil. My pencil is filling up the whole entire thing. I just started writing the things not in the thing. I wrote it like somewhere.
Yeah. I got,
had-
that's as far as I got. I got
I had to-
132,768.
I had to stop at 1,024th because, like, even I can barely read that.
Wow, that's so cool. Now, it's a lot of fun to color in each of these sections. If you want to see what it looks like,
I made the boxes, but I can't write inside of them.
so the coloring in of each of the boxes, I think, is going to be really cool for you guys, and I want you to try it. Now,
I got 8,192.
guys, oh, that's great, Luca. Guys, do me a favor, please. This week, I want you to look at the longest distance you can find. Count how many times you can go halfway. I can almost guarantee you by the 7th, 8th, or 9th time, you are going to be right up against the wall, no matter where you start.
I tried a while. I tried the second hallway and I got it 14 times.
Wow, that is real 14 times. That's fantastic.
It's a really long hallway.
Wow.
Like the light in my house. Well, I just realized something.
What's that?
I could have gone into the garage.
You know
I
what?
could have gone into the garage.
Guys, tomorrow when you're outside, try to do it outside. Isabella, question? Isabella? Oh, Isabella, that's beautiful. Awesome.
But I can still keep on going. Should I keep on going all the way down there?
Yes.
Like it goes all
Yes.
the way.
Keep on going. Hey, guys.
No,
Oh,
that's
Claire.
slowly.
Claire, that's awesome. That's awesome. Hey, guys, guess what? I have to go. I hope you have half as fun as I'm going to have. I hope you have half as fun.
I can't even read what's on this anymore.
Bye, guys.